Okay, so we'll proceed in reusable calculus. The biggest part of mathematics that is unexplored is reusable calculus. Can we use can we use calculus in higher domain? Anyway, reusability is there in mathematics always. Okay, if I learn to know 2 into 3 is 6, then I can use 2 into 3 at many places. Multiplication is reusable, division is reusable. These concepts are reused. If I tend to say that I have 10 by 5 equal to 2, then I would see there are many mathematical expressions where 10 into 5 is required. Rather than doing the computation of 10 into 5, I can search in memory where 10 into 5 is already done. Understand? What is concept of reusability? Why we need reusability? Reusability, we avoid computation. Reusability, we avoid computation and we take whatever has already been done. This is called reusability. Okay, or I would say 10 plus 5 to the power 3. 10 plus 5 to the power 3. How much it will be? 10 plus 5 to the power 3. 15 into 15 into 15. I hope this is very difficult. 15 into 15 is 225 and then into 15 that will be very difficult. Consider that I took time to calculate it and I found the answer and I wrote it. Now I am doing many mathematical calculations and somehow, luckily by chance or whatsoever, I am seeing a place where computation is again there and there 10 plus 5 to the power 3. Now, rather than computing 10 plus 5 to the power 3, can I reuse whatever I have done in the past? This is typically called reusability. Reusability is a very big thing. It reduces the computation time very much. But person must understand the concept of reusability. What the actual science behind the reusability. Consider that I am trying to add 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by 6 plus 1 by 7 up to 1 by n. Understand? Consider I am trying to add 1 by 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5 up to 1 by n. Consider I know this computation. Consider, I know this computation. Now, if I'm going for a very big mathematical equation, and there I'm trying a computation where somewhere as a part of big mathematical calculation, one arena is there where I need 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to 1 by n. I need it. Okay, n may not be exactly n up to 1 by 34. But if I know the n formula, I can substitute out there. Okay, if I have done in the past, the scenario is if I have already done in the past, I can just replace that solution here, fit in here. Okay, what is the carefulness is required? Consider I have a place in mathematics where I have to do 1 by 1 plus 1 by 2 plus 1 by 3 up to 1 by n in bracket whole square. Understand? 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to 1 by n full in bracket whole square. This is what I want. Now consider I have not done I have done two things in the past. One is 1 by 1, 1 by 2, 1 by 3, 1 by 4 up to 1 by n. I have done that calculation. Okay, but the requirement is 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to 1 by n complete whole square. This is what is the requirement. 1 by 1, 1 by 2, 1 by 3, 1 by 4 up to 1 by n. I have done it. Okay, I have done another thing also. 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square. plus 1 by n square. Can I replace this with this? Someone will say, yeah, looks like similar only. You're trying to compute the square of it. Yeah. Then you already have solution for a square. Ready-made 1 by 1 square plus 1 by 2 square, 1 by 3 square plus 1 by 4 square up to 1 by n square. Can I replace this here? The answer is no. You cannot replace. 1 by 1 plus 1 by 2 plus 1 by 3 whole square is not same as 1 by 1 square plus 1 by 2 square plus 1 by 3 square. Both are not same. So these kind of consideration meticulously we have to decide that what I need to replace. But if I have a very big mathematical calculation and then in that I have the way actually I was searching electronic component. So in that I have so many components in mathematical calculation. Okay, rather than computing everything, can I search for ready-made solution that I have already done and then replace the solution everywhere and very minimal thing I need to calculate? What is the best thing about it? The best thing about it is that all the calculation I am replacing from the outside as a solution, all are proved solution. They are proved. They will work for sure, and in that manner our solution will be perfect. Okay, if I calculate everything from scratch, there are chances of error also, but now everything will. Can we use calculus reusable? Can we use calculus in bigger computation where we have already done the solution? Okay, what solution we have done? This is the question. What is the problem is, consider summation x equal to 1 to m, sigma summation y equal to 1 to n. Understandable? And then we have minus 1 to the power x minus 1 by y. Understand? This is what I want. Minus 1 to the power x minus 1 is grandi series. Grandi series is 1 minus 1, 1 minus 1, 1 minus 1, 1 minus 1, and so on. And then I have another series that is 1 by y, that is 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 and so on. Understandable? Okay, this is what the series is, and someone has to find the solution. Is it a very simple one? I don't think so. This is typically not a simple one. Not a simple one. Okay, sigma x equal to 1 to m, sigma summation y equal to 1 to n, minus 1 to the power x minus 1, that is a grandi series, divided by y. Okay, for simplicity, since there are two summation, I can create a matrix. I can create a matrix where x is going from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to m, and y is going 1, 2, 3, 4 up to n. Y corresponds to column and x corresponds to rows. Y corresponds to column and x corresponds to rows. Okay, thank you very much. What is it? What it is? If I take x equal to 1 and y equal to 1, that is top left corner of this, then that is the index is 1 comma 1. And at that time, the grandi series is 1, and this series is 1 by 1, 1 by 1. If I go along the row only, then it will be 1 by 2, 1 by 3, 1 by 4, up to n, 1 by n. Let's talk about second row. Second row, the grandi series, that is x, that will be minus 1 by 1, minus 1 by 2, minus 1 by 3, minus 1 by 4, and minus 1 by n. Can you add it? It will become 0. Anyone will say this will become 0. Wait. There is a third row also. Third row is grandi series will be 1. 1 by 1, 1 by 2, 1 by 3. That will be replica of the first row. Okay, someone will say, I know the answer. Okay, how much it is? If your m, I know the answer for n and it is fixed. 1 by 1 plus 1 by 2 plus 1 by 3 up to n. I know what is the answer. Okay, what is your answer? We have derived it in the past. If people can watch our series, we have already done in the past, and that is ln 1 plus n. ln 1 plus n into n by 2 n plus 1. Natural log n plus 1 plus n by, and in denominator 2 into bracket n plus 1. I'll rewrite it. The answer of 1 by 2, 1 by 1, 1 by 2, 1 by 3 up to 1 by n is ln log of 1 plus n plus. Now we have the numerator and denominator. Numerator is n and by denominator is 2 into in bracket n plus 1. This is what we have already seen in the past. Okay, what about grandi series? If I add grandi series 1 minus 1, 1 minus 1, 1 minus 1 up to infinity, then it will come as 1 by 2. This is what we have seen. Otherwise, it depends upon the m. If m is odd number, then summation with this, then the summation will be 1. If m is even number, then summation will be 0. Otherwise, if m is infinity, then summation will be 1 by 2. Thank you very much. Thank you very much. This is what the ready-made solution already I have. Can I use these two ready-made solution to find the summation? This is a very complex, intricate problem is there. Anyway, how to find the solution? What is required one? Required one is sigma x equal to 1 to m plus m, sigma y equal to 1 to n, and then fxy. Fxy is fxy, 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 fxy means we have to add fxy, fxy, fxy m into n times. Fxy, fxy, fxy m into n times, where first fxy is x equal to 1 and y equal to 1. At any x comma y, it is minus 1 to the power x minus 1 by y. The last is x equal to m and y equal to n. It will be minus 1 to the power m minus 1 divided by n. Can someone add it? Now we will use a fundamental hour concept only, and that is called successive approximation to compute the continuous version of this function. This function is alright fxy equal to minus 1 to the power x minus 1 divided by y is a discrete function. It is not a continuous function. Why it is a discrete function? Because x and y has to be a whole number. They cannot be x and y cannot be a fractional number. It must be a whole number. If it must be a whole number, means x equal to 1, y equal to 1, x equal to 10, y equal to 12. X cannot be 9.5. As a fraction number, it is not possible. This is a discrete function. If I want to use calculus to solve this problem, I have to convert fxy into gxy. Gxy is a continuous function. What is gxy for fxy? Okay, let's take fxy at any x, and x is any x and y, then that is minus 1 to the power x minus 1. That is grandi series by y. That is inverted series. That should be equal to gxy dx dy x to x plus 1, y is y to y plus 1. If I equate these two and find a gxy, if I integrate gxy with dx dy, setting the limit x to x plus 1, y to y plus 1, it must come as exactly minus 1 to the power x minus 1 by y. If I am able to find gxy in this infinite algebraic equation, among the infinite algebraic equation, if I am able to find gxy, then gxy is a continuous version of fxy. How to find gxy? It is very difficult because it is a dual integration. if I take any gxy and integrate with dxdy setting limit x to x plus 1, y to y plus 1, it will come as some algebraic equation which may not be equal to fxy. Then I have to change the gxy in favor to fxy. Keep changing, keep changing, keep changing, keep changing till you come to a gxy where it should be the solution. Okay, I'll give one example of in single dimension, that is 1 by 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to 1 by n that we had done earlier. This is single dimension. Fx equal to 1 by x equal to gx x to x plus 1 dx. It is simple concept. If this is x axis, then this is y axis. X axis, y axis. X equal to x, fx is 1 by x to x plus 1. If I take, there is an area strip that will go and hit a continuous function called gxy. fxy is a vertical. So if I equate fxy as x to x plus 1 integration with gx, then gx will have area from x to x plus 1. That area will be exactly same as fx at x equal to x. If they are exactly same, then we have found the continuous version of fx. Adding all the fx means adding all the sub area. Adding all the sub area is nothing but calculating the integration of gx from lower limit to highest limit. Okay, so if fx is 1 by x, what would be the gx? If I try start gx, then gx will be whatever gx is, dx x equal to x plus 1. Okay, in that manner, if I talk about gx, then gx is gx. Let's take gx as 1 by x only. If I take gx as 1, then 1 dx is x to x plus 1. Answer is 1, whereas I want 1 by x. So we will start with 1 by x. If I take 1 by x, then integration will be minus 1 by x square. I'm sorry. Integration of 1 by x is ln x. I think so, yes. Integration of 1 by x is ln x. Okay, if I take 1 by x, x to the power minus 1, then it will become 1 x to the power 0 by 0. Okay, this is not what we want. So integration of 1 by x is ln x. Ln x, x to x plus 1. That will come as ln x plus 1 by x. 1 plus 1 by x, ln 1 plus 1 by x. We want 1 by x, but we are getting ln 1 plus 1 by x. If I am getting that much, then we can expand it through Taylor series. And if I expand it through Taylor series, then the result will come as 1 by x minus 1 by 2x square plus 1 by 3x to the power 3 and so on. Let's take first two terms. This is what we have done in the past. If I take first two terms, then it will come as 1 by x minus, I'll try again. This is not what we had done. So we will do it again. If I have taken 1 by, if I have taken, if I take 1 by x, then answer will be ln x, and then we can expand it through Taylor series. We can expand it through Taylor series. So this is not the way we should start. We'll try again. Okay, now we have fx equal to gx dx. Then dx equal to dfx by dx. If fx equal to gx dx, then gx is dfx by dx. True. D of 1 by x by how much it is? Differentiation of 1 by x. Differentiation of 1 by x is minus 1 by x square. We will start gx with that. That is the perfect way. Now let's not go through shortcut the way I was trying in a hurry or something like that. Minus 1 by x square. If I integrate minus 1 by x square, the answer will be 1 by x. Limit is x to x plus 1. 1 by x plus 1 minus 1 by x. That will come at minus 1 by x into x plus 1. Whereas we want 1 by x. Minus x plus minus 1 by x plus 1 is extra. To get the same thing, we will, whatever we have taken gx, will multiply with minus 1 into 1 plus x. Considering the net result will come as what we want. So we will try again with minus, sorry, We had started with minus 1 by x square, minus minus plus, x plus 1 by x square. That will come as 1 by x plus 1 by x square, 1 by x plus 1 by x square. We have to start gx with 1 by x plus 1 by x square. 1 by x will be ln x, ln x, x to x plus 1 will be ln 1 plus 1 by x. Now I can expand it and it will become 1 by x minus 1 by 2x square. If I integrate plus 1 by x square, the answer will come as minus 1 by x. The answer that will come as minus 1 by x. Limit 1 x to x plus 1. Then it will come as minus and in bracket 1 by x plus 1 minus 1 by x. Minus 1 by x into x plus 1 minus minus plus 1 by x into x plus 1. X into x plus 1 I can take at x square. There is no big crime in that approximation. So net we are getting 1 by x minus 1 by 2x square plus 1 by 2x square. Sorry, 1 by x square. It will come as 1 by x plus 1 by 2x square. Okay, we are getting 1 by x plus 1 by 2x square, whereas we want 1 by x. So 1 by 2x square is extra here. It is extra here. If it is extra, then we will start again whatever we had taken minus 1 by 2x square. So we had taken 1 by x plus 1 by 2x square. 1 by x plus 1 by x square minus 1 by 2x square. Then it will come as 1 by x plus 1 by 2x square. This is what we will get gxy to proceed further. Okay, now we have gxy, redefine gxy as 1 by x plus gx, 1 by x plus 1 by 2x square. If I integrate ln x and then minus 1 by 2, x square will become x minus 1 by 2 into 1 by x. Ln 1 plus ln x will become again 1 by 2 minus 1 by 2x square. The way it is. 1 by 2 minus 1 by 2x square. Okay, and this side we have minus 1 by 2x. Minus 1 by 2 I can keep outside and limit is x to x plus 1. It will finally become minus 1 by x into x plus 1 minus minus plus x plus 1 if I take as x, then plus 1 by 2x square minus 1 by 2x square plus they will cancel each other. Net result will be 1 by x. This is what we want. Means if I take gx as 1 by gx as 1 by x plus 1 by 2 into 1 by x square, then this is the integration and then limit x to x plus 1, it will come exactly as fx. Means we have found the conversion of fx into gx. Okay, now we can go with the final computation. Final computation of gx will be from 1, that is the minimum. X is minimum is 1 and it is going till n plus 1. Last is n, then n to n plus 1 is the last area. 1 to n plus 1 integration of 1 by x plus 1 by 2 into 1 by x square. 1 to n plus 1. 1 by x is ln x, 1 to n plus 1, ln of 1 is 0, ln 1 plus n. And next if I settle down, it will become plus n by 2 in bracket n plus 1. This is what the solution we have found. This is not available in the book. Now can I reuse it in the dual integration? Dual integration, what we are dual summation, multivariate solution. Multivariate we want sigma x equal to 1 to m, sigma y equal to 1 to n, and then fxy. Fxy is minus 1 to the power x minus 1 by y. Now there are two series is there. Numerator is grandi series and denominator is the inverted series, 1 by 1 plus 1 by 2 plus 1 by 3. Anyway, someone would say, why you are worrying this much? You have fxy, right? Find a gxy. Gxy will be same as the way we try to find for single dimension. Here I have to find for dual dimension. I have to take gxy, beginning gxy, and then I have to keep changing it till gxy dx dy x to x plus 1 y to y plus 1 will become exactly as minus 1 to the power x minus 1 by y. Okay, If people have patience, we will do that also. Probably not in this session. We'll try to do that. How much difficult it is, but anyway. Right now, I can rewrite gxy as c of fxy. Continuous version of fxy is gxy. Anyway, c of fxy, c of minus 1 to the power x minus 1 by y, dy dx. First, we will integrate with dy and then dx. Now, c of fxy, c continuous version of minus 1 to the power x minus 1 by y. The numerator is constant. Now, if I integrate with dy, I can take it out. C of minus 1 to the power x minus 1 and integration of y to y plus 1, c of 1 by y dy. This is what exactly we have done in the past. C of 1 by y is gy dy. This is what we did exactly now only. Fy equal to integration y to fx equal to integration x to x plus 1 gx dx. This is what we had tried in the inverted series. And final summation is 1 to n plus 1 gy dy gx dx. Here it is y. That's it. So here we want final summation. Now what. I'll repeat it again. Okay, the concept is fxy is equal to limit x to x plus 1, y to y plus 1, gxy dxdy. Consider through this I have found gxy. Then what will be the final summation? Sigma x equal to 1 to m, sigma y equal to 1 to n, fxy. This is the concept. What will be the final summation for this full? Limit x equal to 1 to m plus 1, limit y equal to 1 to n plus 1, and then gxy dxdy. Gxy is continuous version of fxy, c of minus 1 to the power x minus 1 by y. Okay, c of minus 1 to the power x minus 1, I can take it as outside and then integration y equal to 1 to n plus 1, 1 by y, continuous version of 1 by y dy. Continuous version of 1 by y we have already seen, that is 1 by y plus 1 by 2 into 1 by y square. But anyway, we are not putting it because we have ready-made solution, and ready-made solution is log of 1 plus n by 2 n plus 1. Just we can replace it here. Now we are moving toward the last integration, that is integration x equal to 1 to n m plus 1, limit x equal to 1 to m plus 1. Okay, x equal to 1 to m plus 1. And then we have now outside we will keep it log 1 plus n by 2 n plus 1. This is constant now for the dx, and in the integrand is minus 1 to the power x minus 1. Dx x is 1 to m plus 1. If m plus 1 is infinity, if you are talking about infinity series, full summation will become 1 by 2. Full summation will become 1 by 2 because this is what the grandi series. So net result will become 1 by 2, and then in bracket log 1 plus n by 2 n plus 1. This is the result. Someone can verify. We will try. This is a very interesting thing. We will try to find out gxy if it is really feasible. Gxy if it is really feasible. If, or someone can use this solution, or we'll try to verify it along the x direction and y direction. This is what we will do, and we will see how it goes along. Amazing, mind-blowing, head hitting in the wall. Someone can try. Please don't mind supporting us. +91 is the India country code, 9483160661 is the telephone number. +91 is the India country code, 9483160661 is the telephone number.